Thank you all so much. So I'll invite to stage to introduce himself our next speaker, Mr. Simon Stromwell. You've already heard his voice with the brilliant question.
Well, we're starting early. We're starting early, so unfortunately you're going to have to put up with me speaking, and often I speak about things that are completely unrelated to the topic I'm supposed to be speaking about. So a small thought popped into my head that I thought I might share, because I need to share it. So who's been involved in network innovation before? Who's been involved with the Network Innovation Allowance before? Does anybody know the criteria for the Network Innovation Allowance? One of them. So one of the criteria is there should be no project duplication, right? Who's familiar with the Artemis project? Who knows what the Artemis project? What's the Artemis project?
It's by EIP1 in connection with Kraken or?
No, it's completely unrelated. NASA, the Artemis NASA project. They're going to fly around the moon, right? It's delayed because they've got a hydrogen leak. Anybody from gas networks? They've got a hydrogen leak apparently because it's a very small molecule that leaks. Anyway, that's not my point. My point is it's due. So the NASA Artemis project would not receive Network Innovation Allowance funding because it's duplication of a project that was run in 1968. It's a repeat project. So my message really is that while the NIA allowance says we shouldn't duplicate things, sometimes you need to duplicate a project because the technology or the way of doing something has moved on. So that was just a thought, and I thought I might share. And now I'll get back to the topic of conversation. Right. Okay. So this is a really high-level idea, and I don't even know if it's a good idea. And I'll explain where it came from. So next slide. I've got slides down here. Next slide. Oh, do I have to? I've got to click, have I? No, I normally have someone to do that for me. Yeah, you can do it. Next slide.
We don't have AI for that yet.
Yeah. I don't charge. You don't charge. Right. This idea came because I watched a documentary completely by accident. I mean, I was just, doom scrolling through Netflix and I found this and thought, I'll watch that. And it was a documentary called The Thinking Game. Has anybody seen it? Who's seen The Thinking Game? All right. So Thinking Game is really, really interesting. So it was about DeepMind, which is a UK-based company. They're based in London, and they've solved the protein folding problem. I won't go into what the protein folding problem is, but it's a biochemistry problem that's really important if you want to synthesize new drugs. And it's been a problem for, 50, 60, 70 years, and they have a competition every year. And OpenAI, who are now owned by Google, and Dennis Hasbris, if I get his name right, they received the Nobel Prize for solving that problem. And they solved that problem through the application of AI, and specifically artificial general intelligence. And what was really interesting is how they solved it. So the first thing is they had unlimited funding, which always helps, right? But they brought together a multidisciplinary team from all different disciplines related to the problem, including AI, put them together and got them to work on the problem. But the really interesting thing is they didn't start with the protein folding problem. If anybody watched the documentary, where did they start? Does anyone know what they started? What problem did they start with?
Computer games.
Computer games. Specifically, can artificial intelligence, to be truly generative, could it learn to play the game Go without being told how to play the game Go? And in fact, they did. It did learn to play the game Go, and it was able to beat the world champion in Go. And if people aren't familiar with Go, Go is a very complicated board game. Apparently, it's the most complicated board game you could play, pretty much. So they basically proved that artificial general intelligence could be generative, and they did a couple of things there. The first thing is they used an agile approach. So what was really striking in the documentary, because I come from an agile project background somewhat, is that when they were filming, I noticed they had scrum boards everywhere. For people who are familiar with scrum boards, the other thing I noticed was that they were solving niche problems to get them to the vision. So they didn't say, "Here's the vision. Let's solve that vision. Let's have a massive plan." They said, "We don't really know how to solve that problem, so let's start here." And if we can solve that problem, we can move on to the next one, and we might discover something new that might take us down a different path. But the bottom line is, they did win the Nobel Prize, they did solve the problem, and they solved it pretty quickly. I think from, the first inception of the idea, I think it was like 3 or 4 years. It was really quick. So really what I'm saying, is some challenges require a coordinated research program and the pooling of resources. And I think there are some artificial intelligence problems that could solve some of the difficult problems we have in energy networks. For example, I intuitively believe that artificial intelligence will make a better job of designing the whole network to minimize resource and maximize utilization and increase flexibility better than any human engineer can. I believe that. In the same way, artificial intelligence did a better job than the biochemists and everybody else in solving the protein folding problem. So some problems are too big. So I think some challenges require a coordinated research program. So next slide. So what is the big idea? I like big ideas. And the big idea is, should we have a coordinated centre of excellence for AI in the United Kingdom that brings together the resources we need to work on specific problems and the tools to solve specific problems in a very coordinated way? And the reason I say that is really, one, because of the experience of the HVDC Centre, which is a national centre of excellence for HVDC. The reason we needed that is because experts in HVDC are hard to come by. They like working with other experts, and the computing power we needed for the HVDC Centre is enormous. And you've heard about that a little bit by RTDS, but if you don't know what they do at the HVDC Centre, they run a national network model, and they basically run real equipment on a virtual model. So on one side of the wall, they have a digital model. On the other side of the wall, they have the control equipment. And they're simulating all of the kinds of things that can happen in a network when you put HVDC equipment on the network. And so you need to solve that together. AI is a bit like that. One, if we all do it on our own, you are not going to get the resource. Anybody tried to hire an AI engineer recently? Does anyone know what salaries they're asking for at the moment? Right. Two, you need an enormous amount of computing power. Is every network going to be able to afford to buy that? So I think there is a case for it. So that's the big idea, is that we should have a national centre of AI, and the ambition should be that the UK could be a leader in the application of AI to energy networks, managing networks, designing them. I will say that doesn't preclude networks working on niche use cases. So I see this as a really big problem, not applying image processing to looking at whether you can detect faults on the network. I think that's relatively tractable. I think we can do that. But there are bigger ideas and bigger applications. And also to work out how are we going to make use of the new Ofgem IA sandbox. I don't think anybody knows really. I don't even know if anybody knows what the sandbox really is. But if we're going to have a sandbox for testing AI, we should do that in a coordinated way. So what are we looking for at the moment? Next slide. So at the moment, I'm not looking for someone to come and say, give me 100 million to set up a research centre. Because to be honest, I don't know if it's a good idea yet. I'm looking for proposals for somebody who's got the time, some of the expertise, not all of it, to go away and think about this and talk to all of the stakeholders as an independent person, talk to all the networks, talk to the AI companies, talk to government, talk to Ofgem, to work out, one, is this a good idea? Two, if it's a good idea, how would we do it? I don't know whether it's like the HVDC Centre where I stick everybody in one building and get them to work on it, or whether it's more of a virtual collective. Is it a good idea? What are the options for pooled research? Who needs to be involved? What are the risks? What are the next steps? And off the back of that white paper is then to put together a coherent plan in the same way they did for the HVDC Centre to say, look, we think this is a good idea. We think it'll bring this benefits to the UK economy and the UK energy industry, and then go and get the funding. Now, some of that funding can come from regulatory funding, because the HVDC Centre was partly set up, I think, on NIC funding in the original days. And some of that funding will have to come from various sources. So all we're really looking for, and I'm you know, I would very much encourage collectives to come forward and say, we'll look at this together. You know, it'd been nice to see a commercial organisation hook up with an academic institution to look at this, but it's really to kind of develop a feasibility paper and a justification and do some of the benefits analysis and all the stuff that I have no time to do, and people in my team have no time to do at the moment, and I probably don't have the skills to do either, to be honest. So that's it. That's the big idea. So it's pretty high level. Thank you.